Hi all, I am here with my new video on chemical bonding and molecular shape. Let's start. In this video, we will learn about chemical bonds and its types. Why do chemical bonds exist? An atom becomes more stable when it acquires the electron configuration of a noble gas. If the valence level of a stabilized atom is the first principal energy level, it will contain 2 electrons. Otherwise, it will have 8 electrons. However, the valence levels of atoms are not isoelectronic with the valence levels of noble gases, means they do not have 8 electrons in valence levels. In order to acquire this state, atoms form bonds with another atoms in a variety of ways. While forming bonds, atom obey octet rule, means bonded atom acquires 8 electrons in their valence levels. Formation of a chemical bond. To become more stable, system's energy must be decreased. This decrease occurs when an atom forms chemical bonds with another. Example, when two hydrogen atoms combine to make a hydrogen molecule, the energy of hydrogen molecule is lower than two hydrogen atoms. Therefore, it is more stable than two isolated hydrogen atoms, as you can see in the graph. There are two types of bonds, ionic bonds, covalent bonds. There are two types of covalent bonds, multiple covalent bonds, coordinate covalent bonds. Ionic bond. A pair of atoms fill their valence levels by transferring electrons between them to form ions with opposite charges to achieve noble gas configuration. In molecule of potassium fluoride, Kf, an electron is lost by K atom and gained by F atom as following. When the pair of ions have been created, their opposite charges cause them to attract strongly, and this attraction is called an ionic bond. An ionic bond is formed in a compound such as potassium fluoride, Kf. The attraction is not limited to pairs of ions. Oppositely charged ions arrange themselves in a regular array which is called crystal lattice. Kf does not exist as individual units. This formula just tells us the ratio of positive ions to negative ions. We call this ratio as formula unit. In potassium fluoride, it is 1:1. To form an ionic bond, one atom must be able to lose electrons, i.e. have a low ionization energy, and the other atom must gain electron readily, i.e. have a sufficient negative electron affinity. Covalent bonding. Certain pairs of atoms do not have a strong tendency to transfer electrons between them. They share electrons between them to make chemical bond. Electron sharing always occurs in pairs. Atoms may share 1, 2 or 3 pairs of electrons. The atoms bond together because the shared pair or pairs belong to both of the atoms. This type of bonding is called covalent bonding. Example, fluorine molecule and hydrochloric acid. There are two types of covalent bondings, non-polar covalent bonding, polar covalent bonding. In non-polar covalent bonding, when both atoms which are sharing electrons to form covalent bond has same electronegativity. Example, in fluorine molecule where both fluorine atoms attract shared electrons equally. Polar covalent bonding, when one of the atom has greater electronegativity than another atom while forming covalent bond. For example, in hydrochloric acid, chlorine atom attracts shared electrons more than hydrogen atoms, so shared electrons are not shared equally. Multiple covalent bonding. In some molecules, atoms share more than one pair of electrons and form multiple covalent bonds. For example, in O2 molecule, oxygen has 6 valence electrons, and in order to place 8 electrons in its valence level of each oxygen atom, it is necessary to share 2 pairs of electrons. This is known as double covalent bond and may be represented by two lines between oxygen atoms as following: O double bond O with 2 unshared pairs of electrons on each atom. Another example of multiple covalent bonding is N2 molecule, where N atom has 5 valence electrons, and to place 8 electrons in each nitrogen atom, it is necessary to share 3 pairs of electrons and form a triple bond between two nitrogen atoms. It is represented by 3 lines between nitrogen atoms with 2 unshared electrons on each nitrogen atom. How to predict types of bond between atoms? To predict types of bond between atoms, we compare the electronegativity of both atoms. The electronegativity difference enables us to predict the type of bonds between two atoms. We calculate electronegativity difference by subtracting the smaller electronegativity value from the larger one. However, first we recognize that no bond is completely ionic or covalent. It is a mixture of both. We can relate the nature of bond to the difference in electronegativities of the bonded atoms. On this slide, there is a table of prediction of bond types. We can summarize the information in a table as following. When we have range of electronegativity difference between 0.0 to 0.4, the bond type is non-polar covalent. An example is bromine chloride. When range of electronegativity difference is between 0.5 to 1.6, the bond type is polar covalent. An example is HBr, where electronegativity difference is 0.9. When the range of electronegativity difference is greater than or equal to 1.7, the bond type is ionic. An example is potassium fluoride, where electronegativity difference is equal to 3.2. In our next video, we will learn rules to draw the Lewis structures of covalent molecules and polyatomic ions. Please like and subscribe to watch my videos. It helps and inspire me to make more videos like this and reaching out more kids and help with their chemistry lessons.